Hello and welcome to another video. My name is Haraldus, and today I want to talk about object-oriented behavioral design patterns. In simple words, the interpreter pattern is like making your own small language and then writing a program to understand or interpret sentences from that language. In this case, I've got an I-expression interface with an interpret method, then a few concrete implementations of the interpret method, such as the number expression that will return a number, add expression which will allow to add two numbers, and subtract expression that allows to subtract two numbers. This is a static parse method that takes an expression string as input, then it splits that input string into an array of strings, and each string then gets interpreted individually. As you can see, if the token is a number, then the number expression gets called. If the token is a plus, then the add expression gets called, and so on. Here is a simple demo. I pass in a string input to the expression parser, and it splits the string, interpreting each individual token. You should use the interpreter pattern when you want to evaluate expressions in a custom language. Avoid this pattern if the rules or the grammar that you're trying to use is complex, as it can become very slow and messy. In simple terms, the template pattern is like creating a recipe with fixed steps, but letting others decide how to do some of those steps. In this example, I've got the beverage class acting as the template class, where most of the steps like boil water or pour in cup are already implemented, but brew method and add condiments are abstract and will need to be implemented by the subclass. Then each of the subclasses have their own concrete implementation of the steps that can vary. You should use the template pattern when you have a general process with fixed steps, but some steps can change depending on the object. You want to avoid duplicating code across classes that share the same structure, or you need to enforce a specific workflow but allow the flexibility in individual steps. The chain of responsibility pattern is similar to a customer service support system. Imagine this: you send a complaint support request, it goes to a junior support agent. If they can't handle it, then it goes to a senior support agent. If it's still unresolved, it goes to a manager. Each one has a chance to handle the request, and if they can't, they pass it along to the next person. This is exactly how the chain of responsibility works. It's a chain of objects, and each one decides, can I handle this? If not, then I'll just pass it along to the next one. In this example, I've got an abstract support handler class. It has a link to the next support handler and a method to handle the request. Each of the concrete implementations override the handle request method, adding their own logic on how to handle the request and when to pass it along to the next handler. Chain of responsibility is great when you want to decouple the request sender from its receiver. Also when you want to give multiple objects a chance to handle the request. You should avoid it if you need guaranteed handling, as none of the objects may end up actually handling the request. If the chain becomes too long or complicated, it can be hard to debug. The command pattern is a way to encapsulate an action as an object. In simple words, it's like writing down an instruction, for example, turn on the light, on a piece of paper. This would represent the command object, and then you can give it to someone, like the invoker, to execute later, or even undo if needed. It helps to separate what needs to be done, the command, from who actually does it, the receiver. In this example, I've got an I-command interface with an execute method, a receiver, this is what does the actual work, and a couple of concrete command implementations. The invoker class, where it's possible to set a command and execute it. Use the command pattern when you want to decouple a sender from the receiver, also when you need to queue requests, log them, or support undo/redo functionality. The iterator pattern lets you access elements of a collection sequentially without exposing the collection's internal structure. A simple example of this is a Spotify playlist, where you can go through the songs one by one by pressing next or previous without having to worry about how those songs are actually stored. In this example, I have a book class with a book collection interface that requires an iterator, the actual iterator interface that can tell if there is a next element and a method to get the next element, then a concrete book collection called library and a concrete book iterator. Now I can access the book collection, getting books one by one using the iterator without knowing anything about how they are stored internally. Use this pattern when you need to support multiple traversal algorithms such as forward, reverse, filtered, and you need the same access to different types of collections. In the Spotify example, the song can be stored in the database and be streamed to your device, or it could be stored locally. However, you use the same iterator to iterate the collection of songs. The mediator pattern is about having central object that controls how different objects interact. so they don't talk to each other directly. You can think of it as a middleman. In this example, I am applying the mediator pattern to a chat room implementation. The iChat room mediator interface defines how users send messages. The concrete mediator manages users and delivers the actual messages. Each of the users gets a mediator, aka the chat room assigned when creating a user, and they can only communicate to other users via the mediator and never directly. You should use the mediator pattern when you have many objects communicating with each other and you want centralized control over that communication. The memento pattern is like a save game button in a video game. It gives objects the ability to save and restore their state without exposing their internal details. This example covers memento usage in a text editor. The editor memento class is used to store the editor state, also known as a snapshot object. The editor is the originator. It's the main object that can create and restore snapshots. Think of saving and undo functionality in a text editor. The history class is the caretaker. It's using a stack to keep track of mementos, the snapshot objects. Common use cases for memento pattern are undo redo functionality. In games it can be used for saving and loading progress. It can also be used in form wizards to step forwards and backwards. The observer pattern is about automatically notifying multiple objects when something changes. So you can think of it like subscribing to a YouTube channel. When you subscribe, you become an observer. When the channel uploads a new video, the subject changes. All subscribers are notified automatically. In this example, I have an iObserver interface for objects that want to receive updates, an iSubject interface for objects that can be observed, a weather station, which is a concrete subject. It keeps a list of all observers, and you can also register or remove them. And when its internal state changes, it notifies all of the observers. Then I got a couple of concrete observers, phone display and window display. You should use the observer pattern when you have one-to-many relationship, one subject and many observers, when you want automatic updates when a subject state changes, and when you want to decouple the subject from its observers. The state pattern allows an object to change its behavior when its internal state changes. The key idea is that instead of using lots of if or switch statements, you create separate state classes and the object delegates its behavior to its current state. In this example, I have an iPlayer state interface with a press play method, media player, a context class holding the current state, and play state and pause state, concrete implementations that implement the behavior of those states. You should use the state pattern when an object's behavior depends on its state, or if you want to avoid complex if/switch statements. The strategy pattern allows you to define a family of algorithms or behaviors and make them interchangeable at runtime. To demonstrate this, I use the basic payment system example. The iPayment strategy interface defines the pay method. Then I've got concrete strategies such as credit card payment, PayPal payment, and Bitcoin payment. These implement different behaviors, and the shopping cart, which is context. So based on the selected payment method, it uses a different strategy object and delegates the payment to it. You should use the strategy pattern when you have multiple ways to perform a task and want to choose at runtime. If you want to avoid lots of if, else, or switch statements, and if you want your code to be flexible and open for extension. The visitor pattern lets you add new operations to a group of objects without changing their classes. In this example, I have an iVisitor interface, item element interface for objects that can be visited, book and fruit concrete elements implementing accept method, and shipping cost visitor, concrete visitor implementing the operations. You should use the visitor pattern when you have different types of objects and want to perform new operations on them. You want to add new functionality without modifying the existing object classes. For example, this can be used for tax calculations, reporting, exporting, or applying discounts. Making this video has been tiring due to the number of different design patterns. At the same time, it was very interesting. Like and subscribe if you found this video helpful. Thanks for watching, and see you again in the next one.